Right now, I think I'd like to try to introduce our landfill engineer, Michael Stubbs. Michael is president of landfill engineering firm Hodges, Harbin, Newberry Tribble, which is based in Macon, Georgia. Hodges, Harbin, Newberry Tribble is the preeminent landfill engineering firm east of the Mississippi. There hasn't been a major landfill project done in the state of Georgia in the last 20 years. It hasn't involved HHNT. Michael is a graduate of Georgia Tech University, and I go ahead and like to introduce Michael. I'd like Michael to talk a little bit about the environmental aspects of the site. Go ahead, Michael.
All right, hey guys. Thanks, T and Ernest. So, like T said, my name is Michael Stubbs. I'm the president of Hodges, Harbin, Newberry Tribble. This is about my 24th year here. Been involved in, I've actually never really counted them, but hundreds of landfills all over the country, primarily in the southeast and dozens just in the state of Georgia. A couple things I want to talk to you just generally about when you're talking about a landfill, and we do lots of them all over the country, is those things that a modern day landfill is designed to protect. And the first we'll talk about in any facility is the groundwater beneath the landfill. So there's groundwater underneath everything. So you want to make sure that you protect that common. The primary means of protection of that common is what we call a liner system. Now, engineers like myself, what we have to stand on is our reputation. And so because of that, I'm third party to this group, and so I get paid to take a look at the job and make independent decisions about how this site and this system would function as it relates to the protection of the environment. And so the first element that we're going to talk about is the protection of the groundwater. The groundwater, I think they're going to drop a section on here. That's great, so I can look at it. Is essentially you spend lots and lots of time and money determining the location of the groundwater and how deep it is, and then any liner system that you place in a landfill is what we call a composite liner system. Number one, it's well above the groundwater. And we take measurements to make sure as the groundwater fluctuates that we know exactly the highest level it'll ever be, and then we build a liner system above that. The liner system is what we call a composite liner system. Engineers, by our very nature, are redundant. We like multiple systems that aren't related to one another that provide redundancy in the protection of the environment. That's exactly what a liner system that you're looking at here in this sketch is. It's made up of several components. First component is, and I'm going to work from bottom up, is obviously separation to groundwater, but the second is a clay liner. It's a very impermeable soil that is placed in very thin lifts, compacted and tested throughout the entire process to where it's very, very impermeable. Also, the landfill is drained to common collection points. On top of that, you have what we call intimate contact with an HDPE. It's a really, really thick piece of very high density polyethylene plastic that is manufactured for this purpose. It sits on top of the clay in intimate contact with it. And what that is designed to do is that part of the engineering analysis is and this is if you had water that stood on top of the liner 12 inches tall, it would take 20 years, and there was a hole in the liner, it would take 20 years for that water to push, one drop to push through the bottom of the clay liner. And so you have a very redundant and protective system. Everything is sloped to a common point. The liner is what we call construction quality assured all the way through by third parties. Everything is tested. And then it's sloped to these collection points. In addition to that, we have a protective cover system that sits on top of the liner. That's exactly what it sounds like. It protects the liner system. Its first job is to protect the liner system. It also is made up of a series of pipes and gravel that convey any liquid coming from the waste to these common collection points. And again, we're talking about waste that's underneath our sinks, each and every one of us. So that's the type of waste we're dealing with. And this water that comes through the landfill from the waste is collected along this liner system and is collected along the common the collection points. The real is really not hard math. It's really simple. Is if you don't want something to leak, you simply remove the water. And so the liner system is a barrier, and a very effective barrier, to prevent anything from leaking through the bottom. But we don't stop there. We simply remove the water from all the collection points. We have ways of measuring the liquid level in the bottom of the landfill. We do that literally every day at the pumps, and we move the liquid off the bottom of the landfill so it can't build up what we call head or pressure on the liner system, even though the liner system is designed to handle it. So we simply remove that wastewater. It's got a name. We call it leachate, but it's wastewater. It's treated very much the same way as wastewater from when you flush your toilet at home. It goes to the same wastewater treatment plants that are designed to treat that material. In addition, we also have outside the facility, we have groundwater detection wells that are designed to detect if anything ever did happen long before it gets very far from the footprint, if there is any indication that there may be a problem below ground. We call these groundwater detection wells. We sample those at least every 6 months, and then a third-party professional specializing in that material, those analysis determines if anything's going on underneath the landfill. And the rate at which the facility, water flows underneath the facility is not, somebody might think, well, it's like a garden hose running on concrete. No, it's, maybe inches or feet a day of migration, not thousands of feet a day. So it's actually a very slow process, even if something did cause a problem. Not only do we protect the groundwater, we also protect what we call commons like vectors. The waste is covered every day when it's placed in there, so you won't have those vectors getting into the waste that could cause a problem. And then we also collect the gas from the landfill. As any of the organics may decay, we collect the gas from that facility. That gas, once it becomes to a certain amount, which is pretty early in the history of the site, that gas can be used for beneficial reuses, a gas-to-energy plant, something along those lines. So we're protecting the groundwater, we're protecting the common vectors that could potentially be attracted to a disposal facility by protecting the waste. We're collecting any gas, and that is a protection of what we call the air, or the air common. Therefore, the facility is, when it's closed up, we call that dry entombment. We essentially put the same liner system on top of the landfill that's on the bottom, and then we monitor that facility for a minimum of 30 years. As the waste continues to degrade, the facility will continue to be monitored, both groundwater and the air permits. So you have groundwater and air permits on the site. In addition, during the operation of the facility, it does rain, and so when it rains, any waste that contacts the disposal disturbed area, not the waste. If water touches waste, it goes to the liner system and is treated as such. If water touches the area that's disturbed, the cover, it is routed to stormwater ponds, and those stormwater ponds are the design from the state is required for a 25-year storm. We design our ponds because it's environmentally beneficial to essentially be well over designed to where not only do they pass the 100-year storm, they will pass the 100-year back-to-back storm. So significant over design, redundancy in the placement of both the liner system, the stormwater ponds, and the air protection system and the gas systems. And like I said, I've been involved in many landfills over the years, and Ernest alluded to it early. The site generally selects itself. There are dozens of things we look at as selection of a site, and this site has everything that's needed for a safe, environmentally protective disposal facility. The soils are there. It is actually really unique to have a facility this close to major transportation routes that doesn't go through any, you come right off the interstate and right into this facility. This is the best one I've ever seen, being so closely located to a major thoroughfare, and once you get off that major thoroughfare, you're right into a very long access road, and then the site is really just kind of tucked in or nestled in between the topography that further makes it extremely unique in the way a facility is usually sited. It's really a lot of advantages to this particular location. The last thing I'll sum up with is I touched on a few of the commons, but we also look at a lot of other studies. These things include floodplain studies, so to make sure that when it does rain in rivers and creeks and streams get out of their banks, that we're not going to impact floodplains. We study things like cultural resources. We want to make sure we're stewards of our cultural heritage. We study things like wetlands and streams and threatened and endangered species. We also look at more social things such as environmental justice issues. There are probably a few more that I might be missing, but for the most, we also look at odor, traffic control, and noise. Those are some that are generally associated with industrial facilities that we all look at. All those studies have been prepared, and like I said earlier, this is just a really good site based on its location. It has all the things that are needed for safe operation of a landfill. They're all right there in the facility. And with that, I'll turn it back over to T and Ernest. Thank you for the time.